Hi, in this video we're going to look at recurring decimals. So in terms of notation they look like this, and basically this dot here means that this 4 is going to repeat. So if I was to write out in long form, it's just 0.44 and these 4s keep on going forever. Other way to see it written, here the dot's only above the 6, so that means that only the 6 repeats. So this is the same as 0.1, and then we have basically infinitely many 6s going after that. If you have a dot over two numbers, it means everything from the first to the last is going to repeat. So here this block of 247 is going to keep on repeating. So it would be 0.247, 247, 247, and again all the way up to infinity again. Lastly, we mix this a bit. If the dot's just above these two numbers, that means only these numbers are going to repeat. So here this will be 0.2, and then it's 43, 43, 43, 43. So first things first, make sure you're okay with how these notations look. So now we know what notation looks like when it's sort of a basic GCSE style problem, which is here are three numbers, just put them in order from smallest to biggest, or biggest to smallest, sorry. So what we need to do here is basically use the notation we've just looked at and write this out in what I'm going to call long form. So here only the 1 repeats, so this will look like this number here. Here the whole sequence, the whole 471 is going to repeat, so write out in long form will look something like this. And for the last one, only the 71 repeats. So now we've got them all in long form, we can see which is going to be the biggest. To do that we can just look at this decimal place here, and we can see that this has to be the biggest, followed by this, followed by this. So this is the biggest, that's my second biggest, and then this will be the smallest. So again, this is just going to be GC questions, and just write them out as a long number, it makes it look a lot easier. Okay, other questions you see, probably the most basic idea is how to convert from a decimal, how to convert from a fraction to a recurring decimal. This we just use the bus stop method. So 2 divided by 3 you should know means the exact same thing as 2 divided by 3, the same as 2 over 3. And we can work it out by using the bus stop method, by working out how many 3's go into 2. So 3 into 2 doesn't go, we've got 2 left over, so 2 carries on, this point also appears right by the first point. 3 into 20, I know 6 3's are 18, so it's 2 left over, 6 3's are 18, 2 left over, and we see here we're stuck in a loop. So that means the answer to this is going to be 0.6 recurring, because the 6's go on forever. Let's see the idea again. Working out 3/11ths is the exact same idea. 3 over 11 means the same thing as 3 divided by 11, and in the bus stop method your second number always comes out to the front, so it's how many 11's go into 3. Again we add some zeros, we go into decimals here. 11's into 3 doesn't go, we haven't used the 3 up, so the 3 carries on. Again, don't forget to put the point up and above. 11's into 3 goes 2 times, because 2 11's are 22, so we have 8 left over. Then 11's into 80 is 7 with 3 left over. And 11's into 30 we've just done, that was 2 with 8 left over. And we can see again we're going to be stuck into a loop here. So here the 2 and the 7 both repeat, so it's 0.27, and both these have dots above them to show that they both repeat on forever. Okay, that's probably the most basic skill to do with recurring decimals. Just use the bus stop method, make sure your second number always goes outside the bus stop. Okay, the main skill for today's video is how to go the other direction, how to convert from recurring decimals back into fractions. And here we're going to use a bit of algebra to work it out. Keyword here, for these questions you typically are always asked to simplify whenever you can. So let's go through this. First thing I'm going to do is write this out in long form, and life look a bit easier a bit later down the line. So 0.444 ... What we're going to do is we're going to use algebra. So this works for all recurring decimals. You're going to say that recurring decimal, we're going to call it x. Okay, and again I'm going to use the long form where the 4's are written out. What I'm going to do here, I'm going to keep times this by 10 until I get two separate things which look the exact same after the decimal point. So if I times this by 10, if I've got 10x here, the point moves one square along. So we've now got 4.44444. Now again, with these recurrent decimals, these 4s go on to infinity. There are infinitely many 4s. So after the decimal point, both these things are identical. Okay, even though one 4's moved here, because there's infinitely many 4s, in essence we haven't really lost a 4. What this means is, because these are the same after the point, I can take these two things away. And if I take these two things away, all those 0.4s are going to cancel out. So I do 10x minus x. That is going to be 4.4 recurring minus 0.4 recurring. So this is why you always want to have the exact same thing after the decimal point, because then they will cancel out. Just simplifying this down, 10x minus x is just 9x. And all the 0.4s cancel out, so I'm left with 9x equals 4. Now we can just solve this like an ordinary equation. When I get x by itself, the opposite of timesing by 9 is dividing by 9. So x is 4 over 9. And then we're done. We have converted x, which was originally my recurrent decimal up here, into the fraction. So just zooming out there, that means 0.4 recurring is the same thing, it's exactly identical to 4/9. And again, if you're not sure, you can convert the other way. You could try and do 4/9 as a bus stop, do how many 9s go into 4, and you would get 0.4 recurring coming out of that. Okay, that is the key idea. Again, this method works for all recurrent decimals. So just to recap the key ideas, we let x equal a recurrent decimal, we then times by 10 repeatedly, sometimes it's more than just once, until we have the same number, the same decimals after the point. Then we take away those two things and we're left with a nice simple equation to get my fraction. So let's see that again. So here we have 0.16 recurring. So I'm going to let x equal this. Because there is only the dot above the 6, only the 6 repeats. And again, I'm going to keep timesing by 10 until I have a repetition after the point. So 10x, the decimal point goes 1 square to the right. That's going to be 1.6 recurring. These two aren't the same after the point. They're close, but they're not the same. So I'm going to keep going. I'm now going to work out 100x. Timesing this by 10, I now have 16.6 recurring. Okay, and now we're getting somewhere, because both 10x and 100x, they are exactly the same after the decimal point. They're both 0.6 recurring. So I can now take them away. So if I do 100x minus 10x, that's going to be the same as 16.6 recurring minus 1.6 recurring. Again, the 0.6s are going to cancel out. So I'm now left with 90x from 100x minus 10x equals 15. And then we're done. Then we just solve this. X is 15 over 90. And now recall what I say for all these questions. You always want to simplify where possible. So I can see that both these things are divisible by 5. So how many 5s into 15 is 3? How many 5s into 19 is 18? And they're also both divisible by 3, which gives me x is a sixth. So if you had a sixth and you could convert it to a decimal, it would give you this. It's worth mentioning now that your calculators can do all this work. However, any exam style question will say prove algebraically, which basically means they want to see this method rather than just type it into your calculator. Okay, and also don't forget you also have a recurring button here where you can do the exact same thing going the other direction. So your calculator can do all this work, possibly to check your work, but the proofs they ask for do tend to be algebraic proofs, which means you cannot use this method in an exam. Okay, just do a couple more of this, just one more of this easy example, or easier, sorry. So let's go through the steps. This one's not too long. First step, we let x equal it. The dots above the 3 and the 6, that means everything in that group repeats, and that includes the 9. So we've got 396, 396, 396, dot, dot, dot. We're then going to work out 10x. That gives me this. And again, we can see that these aren't quite the same. So we work out 100x. That is going to be 36. And then it's 93. And then we have this. Sorry, it's kind of a pest to write down after a while. And then we have 1000x. So we now have 369 point. Sorry, not 369, that should be... Okay, let's correct these. This was 396 at the front. Hence why these are so annoying, because like you have so many numbers, it's easy to sort of get your head confused with what order they actually go in. Okay, looks about right now. I think all my 3s, 6s and 9s are in the right order. So I've done this a bunch of times, and we can finally see that after timesing it by 10 4 times, I have a situation where I have the same thing after decimal point. So I'm going to take away these two terms. So 1000x minus x, that will equal, if I just copy across so I don't make any more mistakes, 1000x was this, and x was just this. We can see they're the exact same after the decimal point. We can now take those two things away. If I do this, I do 1000x minus x gives me 999x. I've got 396 minus 0 is 396. And all these things cancel out because they're always going to be exactly the same. So therefore x is 396 over 999. Can this simplify? Yes, it can. You should be able to see that this top thing here can divide by 3, and the bottom part can obviously divide by 3. So divide them both by 3. Let's use the bus stop method for the top. I then get 132 over 333. Now it's worth checking, can this still divide by 3? The check we have, if we add up all the digits, they should be divisible by 3 itself. So it works out that 132 can divide by 3 again. So again, I'll use bus stop method. And we now have 44 over 111. Okay, and that cannot simplify any further. They have no common factors. Okay, and that's the basic idea. So it's a tiny bit harder, we're going to see in a second, but this is your key idea here in blue. Okay, and as you sort of seen from my mistake, make sure you're really careful what order you put those decimals in. It's really easy to sort of slip around, especially when the numbers are quite similar, like 9s and 6s. So last one to go through is this style of exam style question. Okay, where we'll be able to sort of work out two things times together, and one of them involves a recurring decimal. The best way to do is before you do anything, just convert everything to a fraction. So for example, 1.5, you should know is 1.5, which therefore is going to be 3 over 2. And I'll do the same thing with 0.7 recurring. So let's say x equals 0.777. This will be quite a nice short one. Therefore 10x is 7.7777. Take them away. 10x minus x is 9x. 9x is just 7. So therefore x is 7/9. So I've now got 3 over 2 times 7/9. I just times them together. 3 times 7 is 21. 2 times 9 is 18. Again, always simplify where possible. Here we have a common factor of 3. And this is 7 over 6. You'd also write this as 1 and 1/6, but we weren't overly asked to do that, so I'll leave it as 7 over 6 for now. Let's just see that idea one more time in a slightly harder format. Here we have this question. So we've got 0.16 recurring. This we actually converted a while back. This was just 1 over 6. I won't go through it again. Let me quickly go through 0.72 recurring. So write it out in long form. $10x is close, but it's not the same. The 7 and the 2's are not in the same order. And we do 100x. I'll now get 72.7272. And that is the same after the point as just x. So these two things are the same. So taking them both away. So again, I'm taking away the top and the bottom. So 100x minus x is 99x, and that's going to equal just 72. So x is 72 over 99, and both of these are divisible by 9. So 9 into 72 is 8. So I've now got this term 0.16 recurring with 1 over 6 times 0.72 recurring, which is 8/11. And then times them both together, I have 8 over 66. This then simplifies down by half in both of those terms to give me 4 over 33. Okay, and that's it. There's a lot of questions you're going to see. This has come up in exams in the past, so it's probably worth practicing on. And keep in mind, your technique is you must convert these to recurring decimals before you can times them together. Times with recurring decimals gets really awkward really quickly. Okay, I hope that helped, and thanks for listening.